Welcome to the PACE booth here at SMTAi 2017. I'm joined by Aaron Caplan, who's the Director of Marketing here. Nice to see you again, Aaron.
Thanks.
Okay. So, I want to talk about this new preheater you have. I forget the model number of it right now, but...
Yeah, it's the PH100.
PH100, okay.
PH100.
Okay, and it looks like it's quite a big workspace that you've got there. Can you maybe tell us a little bit about the key features of it?
Okay. Yeah, the PH100 is an IR preheater. Basically has an array of IR lamps underneath, but it also has a ceramic surface that actually holds heat. Therefore, you can use it as a hot plate for LED type rework and repair. LED type assemblies are very, very, let's see if I can grab them here. They heat sink a lot.
Right. Yeah, because they're on aluminum substrates.
They're on an aluminum substrate, so they're designed to heat sink like crazy.
Right.
And essentially, if you try to use standard soldering or repair methods, you're not going to be able to remove or easily replace the components on the board.
So you've got to get a lot of localized heat to be able to remove that because the heat dissipates across the substrate.
Exactly. So what we do is we place a board like this onto this platform, and it brings it up to an acceptable level of heat. Generally, you don't want to go above 150 degrees above the on the top of the board.
Right.
And then you can come down with an acceptable amount of heat using a thermal tweezer like this,
Yep.
or you could use hot air like this right here. And this generates hot air. This is a different an optional accessory to the hot plate.
Presumably that has different heads or nozzles for depending on the device that you're.
You can just remove the head and place them back on using different style nozzles.
Now, I notice also you. There we go. I notice also you got some rails that go around the side. What are these for?
These are for mounting above the board. So what you can do is place these rails in like so.
So are they all magnetic?
They're all magnetic. If you don't like magnetic, we also have a regular style board handling unit that we can place over this that fits precisely. So on here, I would take two of the smaller ones, place it like so. And then place the rails. It's pretty simplistic.
So this just basically gives the board some space off of the hot plate.
Yeah, I had it backwards, sorry. And I burned myself. Yeah. Don't do that.
Don't do this at home, folks.
I tell this to my customers all the time. This is what you get when you get a marketing guy doing the demo. So now you could actually take an assembly, place it on here, and sort of tighten up on it and move it around. So if you were going to remove a part, this is a through hole type part, but now you're above that assembly, and it'll heat up. And very easy to change the temperature. It's got a nice little touch screen. It's you can change the colors of the screen any which way you want. Change the temperature up to 200 degrees C. So you've got a lot of different options here. Can control it from the top of the board, or control it internally, or from the bottom of the board using a thermocouple.
Right. What's the maximum board size you can take on that?
I believe it'll take, it's designed for 12 by 12, but it'll actually go off the board. But it's about an 11 by 11 work surface.
Right. So the heating element's about 11 by 11.
The heating element is about 11 by 11. But what's kind of unique about this unit, a lot of the preheaters out there do not have the IR element. You don't have to be touching the board to actually thermally soak the board.
Right.
But if you have to, you can actually go and touch the board, especially if you're dealing with a flat type of printed circuit board that does not have components on the other side. But generally, we use different styles. You can actually tilt this by putting this underneath here and
presumably get different heights and
get different heights, or bring it all the way down if you want. So it's a really nice system, but easy to use.
Yeah, and pretty versatile.
Yes.
Yeah, great.
You don't have a lot of light coming up. There's a lot of IR preheaters that have that brilliant light.
Yes.
And we're using medium type of IR that essentially soaks the board without being, it's resistant to colors.
Right.
So it doesn't get hot spots or anything like that. So.
Excellent. So quite a uniform heat across the surface.
Exactly.
Yeah. Well, Aaron, interesting product. Thank you for showing it to us today.
Okay. You have a good day there.
Thank you. So here we are to look at the second machine here on the Pace booth. I'm joined by Michael Lucius to demonstrate this machine. Nice to see you, Michael.
Hey, nice to see you too. Nice to meet you.
Right. So this machine is the TF1800. It's a relatively new addition to your stable. So can you tell us about the key features of this machine?
Yeah, sure. So in the past, we had a machine called the TF1700 that was out for about 10 years or so, and we made some improvements and enhancements to it, and it's now the TF1800. Some of the changes we made were to the upper heating technology. It's actually a patented heating technology that we came up with called inductive heating.
Okay.
And it's a coil wrapped around a piece of steel wool, and it heats up, has the ability to heat up really fast, and then blows hot air down through the chamber, through the nozzle to the component. And then at the bottom we use a 400 watt quartz infrared heater. So we're using a combination of infrared heat and hot air from the top.
Hot air from the top, yeah. Okay, excellent. So that lets it heat up fairly quickly. What's the biggest sample size you can take on this?
The largest sample size, circuit board size, we can do 12 inches by 12 inches, and the component size we can do 2.5 inches by 2.5 inches. But we can also go down as small as 0201 components.
Right, okay. And they're pretty hard to rework by hand, that's for sure. What other features has it got? I see it's got some, is that for thermocouples, these sensors?
So it comes with 4 spots for a thermocouple, so we can monitor the temperature of the component and the board, and it'll display on the graph of the software. The heating control is considered closed loop, so you don't necessarily need to have a thermocouple to run the machine. It's more of a reference.
Right. Okay. Excellent. Basically, is this electronically driven or is it manually driven? This top heater.
Everything, it runs through the software. It's point and click on the software, which runs the machine. But it's a stepper motor with an encoder that uses optical sensors to know where it's at all times.
Okay. Is it fast and easy to program?
It's fast and easy to program. When we sell the machine or a customer purchases, we come in for a day, get them comfortable with it, and they're usually feeling up to speed that day.
Right. Okay, good. Fine. So I think that's about it. Is there any other features? What sort of information does it capture on the screen? Do you capture a lot other data?
Some of the data it captures, well, first it's time and temperature on how fast we're heating up the component and the ramp rate. And we can control and pick up the slope on how, like the degrees per second we're going up. It captures, it's displaying the temperature set from the bottom heater, the temperature set from the top heater, and then the airflow rate. Those are some of the main things. And you can put some note comments at the bottom for the operator to help them kind of run the machine.
Okay, so fairly versatile unit. Great. Okay, well, Michael, thank you very much for showing us that today. Thank you for showing us basically the new products here on the Pace booth.
Thank you. Appreciate it.
Bye-bye.